This is exercise 10.3, placing underpass slope protection. In this exercise, we will place underpass slope protection using a civil cell. Note that this exercise shows how to place and manipulate the civil cell. The grading outside the civil cell will not be covered and will not follow standards specified in Standard Drawing 10-3. So let's go ahead and open up Road 2 USP SR99 corridor located within the Chapter 10 subfolder. So once the file loads, make sure we are in the default view in the lower left corner. Then locate the south end of the bridge in the middle of the project, where the bridge meets the abutment. Let's go ahead and select the abutment control feature definition under Linear, Roadway, Model Control 2D Plan, and Bridge, and also toggle on Create 3D automatically. Then using the Near Point Snap, open the Line Between Points tool and draw a line from the PSHL line at the southwest corner of the bridge, and then we're going to draw it across to the PSHR line. So to do this correctly, we got to hover over the PSHL line and then snap near the bridge line. Then use the perpendicular snap to snap to the PSHR line on the other side of the bridge. Then we can use these orange handles on the line to drag the ends of the line outside the PSH line at least 10 feet on each side. Next, open the profile view of the abutment line that was just drawn. If the line was drawn correctly, the line should have a profile elevation of around 720.5 feet. The abutment civil cell is created so that the abutment control line is 1 feet below the PSH elevation. With the same feature definition still active, create a new profile line 1 foot below the current profile line using the Profile Line Between Points tool, and set this new profile to active. Now return to the default view and then open the Place Civil Cells tool under Open Roads Modeling, Model Detailing, and Civil Cells. Within the Place Civil Cell dialog box, click the 3 dots to open the Civil Cell folder. Since the abutment control line will be perpendicular to the bridge, select the T-dot abutment perpendicular civil cell under abutments T-dot DGN lib and click OK. Now in the 2D view, let's follow the prompts and select a few lines. The first line we're going to select is the abutment control, which is the line we just placed. The second line is the PSHL line, and the third line is the PSHR line. And note that the civil cell works in both left and right directions. The selection order for the other side of the abutment placement would be the PSHR line and then the PSHL line. Now adjust the direction of the reference lines if needed. In the civil cell preview, the small red control lines need to be on the outside of the PSH lines and towards the bridge. Note that you should not need to reverse the reference line directions for the civil cell. So right click to reset and then left click to place the civil cell. And then we can turn on the design corridor graphics level to see the civil cell. So this civil cell contains 7 different template drops that will be placed within the civil cell. Each template drop will need a target alias added to continue with the modeling. Next, open the target defined aliasing tool under Open Roads Modeling, Corridors, and then Miscellaneous, and select the template drop that is parallel to the I-65 corridor at the bottom of the screen, which would be the abutment tie-in right. So next, we need to add the corridor SR99 and the terrain model MU065-4 survey DTM as target aliases for the templates that parallel the I-65 corridor. So both for this one that we have open for the abutment tie-in right, we're also going to do it for the abutment tie-in left. So using the same define target aliasing tool, select the following template drops in order and add the corridor SR99 to each one. So we're just going to go from right to left here. First one's going to be the abutment nose right. Corridor SR99. And apply and close. Next is going to be the abutment gravel right. And the abutment main. Then on the left side, we're going to select the abutment gravel left. And lastly, the abutment nose left. So once we do all 7 of those template drops, the abutment is almost complete. And we can go ahead and open up the 3D view to see more of this abutment. Now a parametric constraint needs to be added to the PSHR side of the abutment to tie in the I-65 slope to the abutment slope. So let's go ahead and open the Create Parametric Constraint tool under Open Roads Modeling, Corridor, Edit, and Edits, and select the abutment tie-in corridor. So here we want to set up the lock to start and end as both checked. The constraint label needs to be EC fill tie slope. And the start value needs to be 50%. And the stop needs to be 25. Then we're just going to left click through the prompts. Then we're going to repeat this last step using the Create Parametric Constraint tool on the left side of the bridge. Here we're going to select the abutment tie-in left corridor. And once again, lock to start, lock to end, using the EC fill tie slope. The start needs to be 50, but the stop needs to be 33.3%. And then we can left click through the prompts. And then for this exercise, we will not place the abutment civil cell again on the right side of the bridge. For future reference, remember that that section of the PSH reference lines will be reversed for that side. So lastly, we need to draw a clip shape around the south abutment that will clip the SR99 corridor to the end condition does not continue under the abutment. Let's open the Place Shape tool under Open Roads Modeling, Drawing, Placement, and then Polygon Tools. And we're going to draw a shape around the bridge abutment, and it's going to clip the SR99 corridor under the abutment or the road. And the shape doesn't have to be anything exact, just kind of get it in the ballpark. Then open the Add Clipping Reference tool under Open Roads Modeling, Corridor, Miscellaneous, and Corridor Clipping. Select the SR99 corridor. And then select the clipping shape that was just drawn to clip the SR99 corridor, and that will complete the left side underpass slope protection. And note this would also have to be done on the right side of the bridge as well if the user wants to place the other civil cell. And also this will not change the 2D model in condition boundaries, only the 3D model. Also for details on how to place other T-Dot civil cells, please refer to the individually recorded videos provided by the T-Dot CAD support website under ORD training materials and then ORD civil cell tips and videos. And this concludes exercise 10.3, placing underpass slope protection.